The Haskell programming language is often thought of as an academic tool, useful for teaching students about monads and functors, but not much else. But there are advantages to using Haskell as a production backend language. Better is a company built with Haskell on the backend, and Carl Baatz joins the show today to talk about a blog post that he wrote detailing his experience using Haskell in production. Today he gives an explanation of why a company might want to use Haskell on the backend. From software architecture to testing to hiring, there are plenty of reasons why you might want to use Haskell if you enjoy the language and you find it appealing in terms of its functionality. Before we get to this episode, a few quick announcements. If you're interested in advertising on Software Engineering Daily, send me an email, jeff@softwareengineeringdaily.com. There are more than 14,000 engineers that listen to Software Engineering Daily on a regular basis, so it's a great place to get your product out into the ears of developers or to advertise available jobs that you might have at your company. Also, if you're an engineer that's looking for an open source project to work on, check out Software Daily at softwaredaily.com. This is an open source news and information site about software. It's being led by Jeff Tribble, a member of the Software Engineering Daily community. You can also check out softwareengineeringdaily.com, which is the website for this podcast. You can find links to the Slack channel, my Twitter account, my email. You can find a link to sign up for our newsletter, Software Weekly. And with that, let's get to today's episode. Continuous integration is so useful that I've started using it on my own personal projects. SnapCI from Thoughtworks has the fastest setup I've ever seen. I registered for SnapCI with my GitHub account, and after a few clicks, I had continuous integration pipelines set up for a Node.js application and a Rails application that were just sitting on my GitHub account. And I don't want my users to experience breaking changes, so I want to run a large suite of tests for my application every time I push a change. And SnapCI will run those tests quickly, in parallel, on a worker that SnapCI spins up and takes care of for me. Whether you have personal projects like me, or you work at a company that is looking for the perfect tool to improve the deployment process, go to snap.ci/softwareengineeringdaily. SnapCI embodies the lessons that Thoughtworks has learned from 20 years of software deployment, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. It would support Software Engineering Daily, and you would get to check out continuous deployment. snap.ci/softwareengineeringdaily. Thanks for listening. Carl Baatz is the founder of Better, an online learning platform built mainly using the Haskell programming language. Carl, welcome to Software Engineering Daily.
Thank you very much. Thank you for having me.
So we are talking today about building a company using Haskell as the main language. Why would you do that?
Yeah, why indeed? When we started Better, I had used Haskell in production before at a previous job where we built a financial forecasting model. And for that, Haskell turned out to be a really good fit with its type safety and immutability and so on. So when we were considering languages for Better, we considered a few other ones. We considered Clojure, Python, briefly looked at Java. But in the end, we couldn't see any reason not to use it. We thought that it would be able to do all the things that we needed it to do. And we just thought we would enjoy working with it more.
So you mentioned these desirable characteristics of Haskell, type safety, immutability. For those who are unfamiliar with the language, can you give a brief explanation for what Haskell is? What are the desirable characteristics of it? Why are those characteristics desirable?
Yeah, sure. So Haskell is a pure functional language. It means that the pure refers to the data inside the language, or the values inside the language, can't be mutated. So if you, for example, have an array of numbers and you want to remove the last number, you actually do that by kind of creating a copy of that array that has all the numbers except for the last one. Now, Haskell does this in a smart way, so it doesn't actually create an in-memory copy. It will reuse as much data as it can using persistent data structures under the hood. But that means that it becomes very sort of easy to reason about your code. So that's part of purity. The other part of purity is that you can't access sort of real world things because you don't know whether they'll be there. So you can't access the disk, for example, by default. You can't generate a random number because that's sort of not predictable or not pure. You can't write to disk and those kind of things. So to do those things, which you clearly need to do, you wrap them in a kind of structure called a monad or an IO monad that allows you to do that. But by default, you can't do it. So that's sort of what purity refers to.
So you built this company Better. What does your company Better do?
So we set out to build an enterprise e-learning system. So I don't know if you know about these courses that most employees of banks take, compliance courses, where they have to go through and say, yeah, I know that I can't take money from anyone, and so on. These courses today are fairly old school, so they often assume that the employee has a normal desktop with a big screen, and they don't expect people to use iPhones or iPads or anything like this. And this has become a bit of a problem, and we set out to build a solution for that. So a sort of modern e-learning tool platform, if you want. That also has some adaptability, manages the creation of these courses better with translations and that kind of thing.
So you mentioned that your previous usage of Haskell in production was this prediction, I think you said it was a temperature prediction tool, which sounds like a very different domain than building an online enterprise learning platform. So what were the commonalities between those two applications that made Haskell seem like a good fit?
The previous tool that we built was a pension prediction tool. So
pension forecast
pension plans, basically, so financial forecasts. But you're right, there actually weren't that many commonalities between the two domains, other than both were server-side services that needed to run some logic. But other than that, there wasn't much commonality, which to me sort of says. Or that's an indication, I think, that Haskell is a general-purpose programming language. It can deal with many different kind of domains.
So does the Better application have any types of unusual requirements?
Not really. No, I think like with most enterprise software, we needed browser support for very old browsers. I think IE6 actually we supported them, and there is a minor thing around these courses get deployed, often announced in one go. So you can get a very high load initially, where all sort of 100,000 employees of the company get the email to say you now need to do your course, and then everyone kind of goes on at the same time. But that's the only thing. Otherwise, there weren't any particular requirements.
I feel like I hear about Haskell mostly being used in these domains where there's a really, really heavy backend component, something like spam detection or financial processing. I mean, I did a show about OCaml a while ago, which was what Jane Street, that trading company, uses. I think OCaml has some similarities to Haskell. But a lot of the web applications that we build these days, and I think what I imagine Better to be, I haven't looked at what it actually is, but what I imagine it to be is an online learning platform that's mostly the front end. It's mostly front end focused. So it seems like the back end, you would want to just use like some battle tested tool like Ruby on Rails or some kind of JavaScript thing like Express.js. Give me an idea of how your experience with Haskell, like when you decided to use Haskell, what was the projected experience that you expected to have in terms of doing the backend development relative to how somebody would have been using Express.js or Ruby on Rails or one of these more commonly chosen backend choices for web applications?
Yeah. So I think the expectation was that we would need to spend a bit more time on perhaps writing some libraries or some functionality that the Haskell ecosystem didn't provide, compared to, as you say, Node, the Node ecosystem, which is a huge ecosystem and lots of libraries, and Ruby similar. So that was certainly one of the expectations, and we factored that in and thought that was acceptable. On the other hand, I think we actually expected Haskell to provide much more stability and safety, if you want, than either Node or Ruby. And you're right that they are certainly battle-tested. The frameworks are battle-tested, but the language that you use to write your actual logic in is less so. They have more room for mistakes, and you need to use tests to cover that. And Haskell removes a lot of the bugs that are possible with dynamic languages like JavaScript or Ruby. So that was I think the general expectation.
Right. So you would trade off some of the consistency in terms of how other people have, people have well documented experiences with Express.js and Ruby on Rails, and maybe they have plenty of Stack Overflow answers to these types of problems that you might run into. But you may spend some extra time in that area of the application development, but you're going to save time in the testing process. So can you give an example of like types of tests that you did not have to write because you were in the domain of Haskell?
We wrote very few tests. So I think the answer is most tests. We did test logic, so core logic. We had a kind of rebased model for the courses that used sort of like a Git type data structure. And for that we needed the logic to work and be solid. So we had tests for that. But other than that, many of the things you end up normally writing tests for, the type system will take care of. So you know that when I pass something to this function, it will be of this type. So you don't have to check that this is not null or that this is an integer or that kind of thing.
Now there are these languages like TypeScript that impose a more rigorous type system on top of JavaScript. Could you have used this to similarly avoid these types of errors that might arise from a dynamically typed programming language?
Yeah, so any type system tries to avoid these kind of errors, and this is the main purpose of a type system. So TypeScript certainly goes some way towards that, and in fact we used TypeScript for our front-end code. So that helps. TypeScript doesn't have as powerful a type system as Haskell, and it infers less, if anything, I think. So it takes more effort to use it and get that benefit, whereas in Haskell you get a lot of that benefit pretty much for free, because it infers the type. So you don't have to annotate all the code you write in the way you have to in many other type languages. Although you're right that you get some of that benefit in those languages too.
But they're more verbose.
They're more verbose. They're not quite as sophisticated. So the kind of things you can express in Haskell are better than in many more common languages. For example, in most languages, you can express that the input to this function is a integer and the output is a string. So that's a very common thing. But you might not be able to say that this integer is or this value needs to be a member of these two type classes, and the output is a function of sort of those two type classes or those two types. So it's just because you can express more with the type system, you can also add stronger guarantees to the code.
Describe to me the architecture of Better. What is the relationship between the client and the server and the database?
The Better architecture is pretty simple. We have a Postgres database, and we have a backend web server, which is a binary compiled from Haskell. And we have two clients. So one kind of single page application for the administration and the course creation interface, and one learning client for those taking the courses. And the reason we split those up was that the learning client needed to be compatible with more browsers than the administration interface did. And that's pretty much it. Then that sat behind an Nginx server. And on top of that, we then had an ELK, so Elasticsearch Log Stash and Kibana Stack to do monitoring and logging. Log analysis.
So give me since the server is the component that was actually written in Haskell, Give me a more in-depth view of how the server works, how it was broken up. Was it microservices or monolithic? What's the interaction pattern between the server and the client and the server and the database?
We actually started off with more of a microservices architecture, just worth mentioning up front. So we had sort of Haskell compiled to several binaries, each that was a web service, and then talk to each other. But we found that was too much overhead, especially in the small team that we had, and we didn't really get any benefit from it. So we moved to a monolithic architecture, and that worked out very well. The backend just talks to the database standard connection. The client actually, or the single page application client, the admin and the course creation client, was uploaded to the database. And then the server, the web server, decided which version of this client to serve depending on who was logged in. So that we could say, for this customer, they are a bit more conservative. They want the battle-tested, admin and course creation interface, but without the new features. But this other client wants new features. So for them, we toggled a little switch in the database that said, well, when this person comes to the site, we serve this version of the client instead.
So tell me more about how you started with the server. What kinds of tools and libraries are available in the Haskell ecosystem? I mean, like starting with a Rails application or Express application, just say Rails new or Express new, and you get bootstrapped with all these little components that make it easier for you. Is there an equivalent tool in Haskell?
Not quite equivalent, I would say. I think it's fair to say that there is a bit more manual work to kind of figure some of that things out. Recently, a packaged sort of build tool called Stack has been developed and released a year or two ago, and that has made starting with a new Haskell project much more convenient. So that doesn't help you do the, set up your endpoints and the web services and the web framework the way Rails does, but it does help you start the Haskell project itself. And that does have commands like creating a new project and the boilerplate for that and so on. So that's very helpful. In terms of sort of web frameworks, there are web frameworks, but they're not sort of sophisticated or beginner friendly, I guess, as Rails would be. It doesn't do so much of the boilerplate.
So Stack is this cross-platform program for developing Haskell projects that you mentioned. Mm-hmm. What are the parts of the software development lifecycle that Stack helps with? If it's not exactly a Ruby on Rails level, plug and play tool, what does it help with?
Yeah, Stack helps with kind of package installation. So whenever you run you set up a new project, you want to use a lot of libraries that other people have written. So it's a way of saying which libraries you depend on. So it does the dependency management, and you can say I depend on library X version bigger than 2, and that kind of thing. And it installs those packages, so it downloads them and sets them up so your compiler can access them. It also does project isolation, so it'll make sure that you can use different compilers for different projects and that kind of thing. And it shares the compiled version of the library. So because this is not a dynamic language, you actually have to compile these libraries before you can use them. And that takes time. So this allows you to share those assets locally. So you get some efficiency there.
How
so
rich?
Very much NPM also.
Okay. So how rich is that package ecosystem? Are there packages for everything you could need?
No, I think that would be an exaggeration.
Okay.
So the Haskell ecosystem is decent, but it's not as big as Ruby or Java or Node JavaScript would be. But it is fairly mature. Like you can find many things, and if you develop open source kind of Unix software, you will find most of what you need. I think you will find that the support for commercial things like Microsoft SQL bindings or Oracle database bindings is lacking. And there are, when we did this was a few years ago, we wanted to connect to the Mandrill API for sending emails. And at that point, there wasn't a Mandrill API bindings, which there would have been in Python or Ruby or JavaScript. There is now. Actually, we didn't create that. Someone else did. So things are improving, but you will find some gaps in the ecosystem.
So in that type of situation, maybe Mandrill offers just some RESTful API and you have to write your own Haskell bindings to communicate with that RESTful API.
Correct. Yeah, that's right. Which is all very doable, but it isn't as easy as just installing a well thought through and developed library.
Yeah, exactly. I mean, that's the type of thing that people really just get used to. Rails or whatever the gem installation process is for installing some super easy hook into an API.
Yeah, and that's absolutely fair. And I think that's one of the sort of more prominent downsides of Haskell today. So it depends a lot on what kind of things you're building. You have to weigh that against the benefits of Haskell.
Is that ecosystem getting better? Is there a growing community of people who want to use Haskell in production like this?
I certainly think so. That's my impression. You referenced the Facebook story earlier, the spam filtering thing. So, we didn't have that 5 years ago. There wasn't a big company using Haskell for a sort of production it's a critical tool. And there is now, and I think that helps. And the interest in Haskell has been growing. I think the general interest in functional programming and functional approaches have grown tremendously in the last 5-10 years. We see that in the web sort of community, if nothing else, with React is a fairly functional approach to things. Mm-hmm. You have a bunch of libraries there. So the interest in functional programming is increasing, and Haskell is today the sort of purest version of a functional program that is kind of practically useful, I would say. Doesn't mean it's the only one or necessarily the best one for all projects, but that means that people are interested in using Haskell more.
Wealthfront is an automated investing service that saves you time. As an engineer, your time is valuable. If you want to invest, but you don't want to spend significant time evaluating your portfolio and allocating assets, take a look at Wealthfront. Go to wealthfront.com/SE Daily to open an account today and get a special offer for Software Engineering Daily listeners. $15,000 managed for free when you open your account. With traditional investment services, there are many humans in the loop that are doing things that Wealthfront automates away. When you pay the commissions and account fees of these traditional investment services, you're paying for work that could be done by a computer. So don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE Daily. It would support Software Engineering Daily, and it would introduce you to the world of automated investing. Wealthfront.com/SE Daily. Thanks to Wealthfront for being a continued sponsor of the show. Now let's get on with the show. Are there design patterns that you keep in mind when you're writing a Haskell backend?
Yeah, it's a good question. I don't know. There aren't sort of in the Haskell community. I haven't heard people talk about design patterns in the same way that you do in the object-oriented community. There certainly are patterns, but many of them sort of are encoded as code. And there is a feature of Haskell called type classes, which is very similar to kind of interfaces in Java, if you want. And they encode these kind of structures. You might have heard the names, they call functors or applicatives and monads and monoids and so on. And these are a form of patterns. Now, I don't know if they would be called design patterns because they're code, they're kind of library, but I think they serve a very similar function. So if you know that you need to solve some problem where something can fail, you have some function, it takes some input, and maybe it produces some output, but maybe it fails, then you kind of know that, I need to use a monad for that, and that's the right way to do that. So in that sense, I think you could say that they are design patterns, but it depends a bit on your definition of the language or the phrase, I think. Does that make sense?
Yeah, it does. And I mean, so you mentioned you kind of defined a monad. Can you talk a little more about a monad or a functor or an applicative, and why are these concepts found in Haskell and why are they rare in other places?
Yeah, it's a good question. Actually, I don't think they are rare in other places, and that's the funny thing. I just think they aren't named or sort of explicitly used in other places. They tend to be kind of ad hoc created, and people don't realize that that is what they're doing. So there is a sort of the simplest kind of pattern type class that we can look at is something called a monoid, which is sort of sounds quite mathsy, and the term definitely comes from maths, but it just means that if you have two strings, for example, and you want to concatenate them, then a monoid describes exactly the functionality you need to do that. So if the string is an instance of monoid, I know that I can concatenate two strings. Just like a list can be an instance of a monoid, it can sort of adhere to this pattern if you want, and then I know I can concatenate two lists. And if I come up with my own data structure, say I have a configuration file with some kind of tree structure, I then can make that an instance of monoid, and then I know that I can just concatenate these, and the logic for how it does that is up to me. Maybe some of the fields are lists and they should just be concatenated. Maybe some are atomic sort of values, and you pick the one that is sort of to the right in the right version of that append, or something else. So monoid is really, it's append, and it also has a identity value, but that's pretty much it. So even though it might sound like a sort of scary, weird concept, it's something you use every day in any language, and Haskell has just abstracted it out and given it a name, and you can then reuse the symbols and the syntax and so on for that in whatever you come up with. So that's a sort of monoid. Does that make sense? I can explain monad as well if you want, but
no, I think that's perfect. I think these are important concepts. It's funny though. It's like people. I think these are hard for people to grasp in terms of a podcast. These are the types of things where you really have to see them in practice in order to understand what they are, which is fine. So, but talking more high level, you mentioned that the testing process basically changes in Haskell. You don't have to write as many tests, or you didn't write tests. Does that change in workflow? Does that propagate to the deployment process as well? Like if you're not writing tests, maybe you can't have as much of a continuous deployment pipeline where you have these automated tests running as you're deploying. Maybe it reduces the number of steps in the pipeline. Give me a description for how your continuous deployment process, or if you even have a continuous deployment process, how does that change when you move to a language like Haskell?
So it doesn't need to change. So in Haskell, the compilation stage, you can think of that as your kind of basic test suite that tests for basic consistency in your program, that you're not multiplying a string and an integer or doing something silly like that. That's what your compiler will test for you. So those things that might have been tested by explicit tests in Ruby or JavaScript, the compiler tests. So that's kind of your first step. So if you had a continuous sort of deployment process, you need to compile it, and that would be your first kind of step, and it could fail, and then you roll back. But it doesn't mean you can't write tests. So depending on the requirements you have on your program, on like how correct does it have to be, how costly is it if there's a bug in this, how costly is it if we deploy something to production that fails in some way, depending on that equation, and that's really a business trade-off. You can decide to write as many tests or more than you would in a dynamic language. The only point here is you don't need to write the very basic tests, but the logic tests, the business logic tests, that you do want to test in some cases. And to be clear, as I said, we did test some of that, the things we thought were really critical and that would be very costly if we got wrong, these kind of rebase operation that would mess up data in the database. But the other things, we made a call and we said, well, yeah, we could write tests for that, but it's costly, and the cost of having a problem and fixing them is less. And it turned out we actually haven't had that many problems. But that was the kind of trade-off we made. Does that answer the question? Does that make sense?
Absolutely. Yeah, totally. So is it hard to hire Haskell engineers?
So I would prefix this by saying I think hiring is always tricky. And that's partly because you're trying to fit so many things, like you need skill and you need personal fit and cultural fit and motivation and location, depending on whether you do remote work or not. So it's always hard to hire people. I think compared to other languages, our experience was that or impression was that Haskell gave us a benefit. I think today there are more people who say that they want to work with Haskell than there are employers who offer jobs to work with Haskell. So in some sense, it's a bit of an employer's market. But so it helps. It helps stand out. It helps attract people who are genuinely interested in software development. I think otherwise you wouldn't necessarily be into Haskell. So I think it helps. So I think you do have an advantage. I mean, yeah, people aren't going to say, yeah, I'll give up my job at Google and come work for you for free to build, I don't know, something really boring. But I think it does help.
So were the engineers who applied, do you think they were more skilled on average? Because Haskell is kind of a niche language. You can't just have some university training in Java or C# or whatever your university teaches you, and you kind of have to have some initiative to go off and learn Haskell on your own. So is there some degree of selection bias there?
I think there is a degree of selection bias. I think I would be a bit careful to say that they're necessarily kind of better overall engineers. I think on average, people who applied to us were more motivated. They were more intrinsically motivated to develop software. They were pretty curious and sort of keen to learn new things. So Haskell can seem quite intimidating to learn. And if you kind of do that on your own and decide to learn what all these monads and stuff are, then that shows, I think, an above average interest in learning new things. But again, this is, of course, a generalization. It doesn't mean that they are necessarily great and experienced engineers who can make good trade-offs, like many were. And we got some fantastic sort of applicants who had it all, as it were. But of course, you can learn Haskell, in your room and after university and be very excited about that, but not have kind of seen the real world stories of how you can over-engineer things and how things can go wrong. And I've certainly made those mistakes myself from time to time. So, yeah.
So how does the usage of Haskell, does that affect the overall culture of the company and the way that the product development cycle works and the way that people, I don't know, pick up tasks on a Scrum board? Or how does it change the overall culture and the development of software at Better?
I think it's hard to make a very sort of clear statement about that. I would say it's hard to separate it out from the kind of people we hired, what we encouraged, and so on. But I think Haskell, we can attribute some of it to Haskell. And again, it comes down to this idea that if you have decided to learn Haskell and you like using it, you probably really like software engineering. Sort of intrinsically, it's more than just a job for you. And you probably are intellectually curious. I mean, there are plenty of other languages out there that are really good and can get your job done. And Haskell, it seems a bit more complicated. There are concepts that are unfamiliar in other languages. So you have to be a bit more curious, I think, to sort of be really keen to do that. And that does have an effect on culture. I think some people describe the culture as a bit academic at Better. And I think that's probably fair. Like, I would probably say that intellectually curious, academic can have some bad connotations. But yeah, I think there was some impact there or some causation there.
Well, it's funny because many people would say Haskell is this academic language. It is a language that is taught in academia to make students understand certain concepts around functional programming, like monads or whatever. So maybe there's some correlation there with the academic environment, the academic culture at Better.
Yeah, I don't. Maybe it's I think the reputation for being an academic language is understandable. Like, it does come from academia. Like, it was invented by committee, no less, and it is taught, I think, in ways in academia. At least I was taught Haskell in ways that were super unpractical. When I was taught Haskell back in 2003, we were told to write a Haskell function, a pure Haskell function, and then manually translate it into an imperative language, which just screams you can't use this in the real world. But that, I think, is an unfair. Like, that's not how it actually is. Like, you can use Haskell in the real world, but that reputation has stuck, I think, and I think that's unfortunate. That said, being academic, it shouldn't be taken as that's just a bad thing. Like academia has come up with a lot of good ideas that work really well in practice that we use every day. So it's a double-edged sword, and I think it needs a bit of sort of balance.
Yeah, and there are a lot of developers who played with Haskell briefly in college, but maybe they haven't touched it since then. So how much knowledge does a developer need in order to know how to use Haskell in a full-time context? Like, can you just have taken programming languages in college and picked up a little bit of Haskell there? And is that enough?
It depends on how quickly you need to be productive and what your sort of what the pressure on you will be. So in a startup, I think it's fine because you can control most of the code base and you're it's greenfield. So you can kind of just, as long as it works, it's okay. And then you can learn along the way. If you're a bigger company and you have very high sort of pressure to produce, then you probably want to make sure you're comfortable with the language before you say, now I'm going to use it in production and do some very critical things with it. It's possible, but as always, just that to me doesn't seem prudent. Like, you want to know what you're getting yourself into. In terms of learning, so like we hired a developer who hadn't really used Haskell before. Like, he knew what it was and he knew he was interested in it, but he had a physics background and he hadn't been a professional developer. And he came to us. We hired him because we liked his motivation and we thought he was smart and so on. And he ended up becoming productive very quickly. This was with the help of more experienced Haskellers, which clearly helps, and not everyone has that opportunity. But it is possible. Like, it's not. Yes, there is a lot to learn, and it's different from other languages. But there are many things that you need to learn in other languages as well to be sort of production worthy and ready.
Certainly. So we touched on this a little bit earlier, but OCaml is this language that I've heard of in production that has some similarities to Haskell. Do you know if you would have gotten similar benefits if you would have used OCaml?
Yeah, so I don't have any real experience with OCaml, so I'm not the right person to ask. From what I understand, yes, we would have gotten similar benefits from it. I can't really say how much better or worse would they have been compared to Haskell.
Okay.
That's a question for someone who has more extensive experience with both languages.
What about a language like Scala or one of these other JVM functional languages? Would you have, I guess with these languages, you probably would have had the same problems that TypeScript would have given you with the verbosity?
Not necessarily. So I think Scala should be less verbose than Java. Again, I haven't used Scala in production or anything like that, so I could be wrong here. I know that Scala, from what I've read, Scala doesn't have as good type inference as Haskell, so it might be a little bit more verbose. But its type system is clearly inspired by that and similar. So it does provide many of those benefits. And of course, I would say that it's worth pointing out that if you use Scala, you do have access to the Java ecosystem, which is huge. So that is certainly an advantage. There are actually two projects that are trying to do a more Haskell-like language for the JVM. So there's Frege, which is fairly recent, which is writing a dialect of Haskell for the JVM, which is lazy and pure. I don't know how mature it is yet, though, to be fair. And there is someone who's experimenting with a JVM backend for the kind of de facto standard Haskell compiler called GHC, so that the idea would be that you could compile your Haskell code to Java bytecode and run it on the JVM. But again, none of those, I think, well, as far as I know, they're not. I don't know if they're production ready, but people are certainly looking into it. And Scala is, of course, a popular alternative to those who kind of want to use Haskell but aren't really allowed. But that's not to say that it's not. It's worse. It might not be. It may well be better for all that I know.
Have you talked to any other companies that use Haskell as their main language?
Yeah, I know of a few companies who do.
So what do they say about Haskell? Do they have similar experiences that you've had it better?
Yeah, I think so. So there's a company in the Netherlands who basically create parking guidance systems, and they use Haskell, and they seem incredibly happy with it, and they use it for actually the website of it as well, which we didn't do it better, and seem very happy with that. And they made similar points about hiring and that it's surprisingly sort of nice to. The applicants you get are very good and so on.
What kinds of domains should not use Haskell?
So I think Haskell is suitable primarily for sort of server-side services, server-side applications. Like, I haven't heard of anyone who uses sort of Haskell seriously for building desktop applications or iOS applications. It's a garbage collected language, which means that you can't really use it in real-time systems. The binaries are fairly large, so you don't necessarily want to embed them, and that has similar problems with the runtime and so on. And for games programming, you can do certain games, but if they're real-time, again, garbage collection kind of stops you from doing that. So there is, the other popular variant now, of course, is web programming, so compiling to JavaScript. There is a story for doing that in Haskell. It's called GHC.js, and it's come a long way in the last year or two. And people are using it. And as I said, I know some people are using it in production, but I would be probably a bit hesitant to do that. To me, I wouldn't be comfortable using it in production, but to be clear, that's not saying that you can't. So I think the clear use cases is services. People use it for compilers. It's very, very popular for writing compilers and very suited for that. But of course, that's a reasonably niche use case. But in general, web services or services are run on the server. That's the main use case.
Okay, so to conclude, the next product you build, or the next company you build, are you going to use Haskell?
Yes. If I have a choice in it. But yes.
Okay, Carl. Well, thanks. This has been an awesome conversation. I'm really glad to have done some coverage on Haskell in production.
Perfect. Great. I'm very happy to talk about Haskell, and thanks for having me.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again, Symphono.